All right. So we made it. That last week was kind of the end of our HTML and CSS phases. We are going to continue to use HTML and CSS for the rest of the course, but from here on out, we're really focused on programming and making things happen in an interesting way, right? So, hopefully when we get our jobs, we're not being paid to just make changes to websites. We're not just updating text. We are making things interact, right? We're going to connect to databases. We're going to create interactivity. We're going to make products that are actually useful and functional. So, what is JavaScript? JavaScript, just as like a brief backstory, was invented in the mid '90s, early mid '90s, by an engineer that was working at Mozilla, right? So at the time, they had a browser. This was, I don't know, for those of you that are old, right? When the internet was first available, browsers were not free, right? The internet at the time, you'd connect to the internet, and what you did when you were connected to the internet was not generally that you would pull up websites and browse around. There was FTP. You'd join internet relay chat. You would maybe use ICQ Messenger. Some of these tools. At the time, there was the thought that browsers were going to be a product that had to sell itself based on the number of features that they would add. So at the time, it was kind of the Wild West. Internet Explorer had a browser. Netscape was actually founded as a company by some of the people that were originally a part of the university project that had developed the Mosaic browser. And so Netscape was looking for features and looking for functionality that would make their browser more attractive to customers and make it so that customers would want to buy their browser instead of buying a competing browser. And they had an idea, which was, hey, let's add a lightweight programming language that we can have inside of our browser here that will let us interact with web pages and make it so that the content can be a little bit more dynamic. And so they invented this excellent little programming language. They were getting ready to launch it, and right at the last second, they decided let's tag this name. Let's give this name JavaScript because there was a very popular programming language that was just released by Oracle called Java, or actually it was Sun at the time. And so they said, let's make this JavaScript, and so let's hopefully hitch ourselves to that bandwagon of marketing, and let's get this out the door. At the time, it was kind of just a novelty, right? It was stuff like, hey, you click this button and the button turns blue, or you like hover over this drop down and the drop down, and the element adds other elements as a drop down. There was no idea at the time that this was going to be a formal part of the infrastructure of the internet that we know and love today. Back in that day, there was no background interactivity. We couldn't make requests to servers and things like that. JavaScript was purely a stylistic, change the way things look and feel when the user is on the page doing things. But what happened is there was so much interest in building websites that were interactive like that what eventually happened is that Microsoft, who was the other major browser manufacturer at the time, said, hey, this is pretty good. We're going to implement our own version of JavaScript. And they even gave it a different name. What was that? Gosh, what was their name at the time? It had a slightly different name. But they both basically did the same sort of thing. And that really kicked us off into the mid to late 90s, where things were getting really interesting. And so we go back and forth, where new features would get added to the programming language of JavaScript independently by each browser manufacturer. So, the early 2000s were really kicked off. Was it called TypeScript at the time? Okay. The early 2000s, like the web renaissance that really kicked off that first internet bubble, was the fact that Microsoft had invented a technology for their version of JavaScript called XML HTTP requests. And that let you, with JavaScript for the first time, make requests to web pages behind the scenes. So you click a button, and JavaScript itself would make a request to the server and then update the contents of the page. This was kind of revolutionary, and it let us have our first truly interactive web products that let us load one single page and have the JavaScript behind the scenes update all of the content of the page as we navigate around, rather than going to a bunch of different pages separately. In the early thousands, at some point we realized, hey, this is stupid that every browser is working on implementing features to JavaScript independently. So they invented a standards organization that eventually kind of normalized all these different competing standards into one specific version that is now the formal specification of JavaScript. And that organization sometimes is referred to as the ECMA script implementation. ECMA is the formal specification for the JavaScript programming language. ECMA script. So it's ECMA script. ECMA is the organization that ECMA International, right, is the organization that is responsible for the standards of the JavaScript programming language. Okay, and they've been in charge of it, since 2008. Cool. At the time, right, if you guys remember Flash, for example, Flash was the plugin that let us build, cutesy little cartoons and little video games on the internet. Flash had their own implementation of JavaScript called ActionScript. That was kind of like JavaScript. It was the same fundamental programming language, but the language itself was implemented with the concept of running inside of a Flash plugin inside of that virtual machine. So JavaScript as a language started out being web specific and has kind of taken us along this journey over the last 20 plus years, getting better and better as we go. And so now the version that we're at today, and why we're learning it in this course, is that we're going to use it for both interactivity on the web pages as well as back-end server programming. Any question about kind of the history of JavaScript? It was a very exciting time back then. Go ahead, Kareef.
Yeah, just to clarify, so CSS and HTML, that's usually referred to as front end, and now we're looking at JavaScript, which is the back end.
No, so we're going to first start by learning JavaScript on the front end as well. So the front end generally refers to anything that happens inside of the browser of the user. That's all front end. Okay, it's the part that you click. In a couple of weeks, we're going to start learning to use JavaScript on the back end, which is the stuff that runs on the server, right? So all of the content that is being sent, when we click on this, I don't have it. I'm getting a file real quick. Index.html. Right. When we click on this little open with live server, that's running a server software on our computer that is actually serving the content to our browser. Anything on the client side is front end. Anything that happens on the server is the back end. So all the database connections and stuff like that, that's generally back end code. We're going to be using JavaScript in both places. HTML, CSS, and JavaScript on the front end is really like the first half of this course, and then JavaScript and databases on the back end is the second half of the course. Okay, cool. All right, so how do we implement JavaScript in our browser? Actually, it's perfect that we created this. So I've got here a blank, brand new little project. I'm gonna make this bigger so we can see it. Right. Cool. And I'm gonna create a little bit of boilerplate, right? So fun with JavaScript. So there are a couple of ways to implement JavaScript in our pages, right? So if we wanted to write some code here, there are two main methods of doing that. The first is we can come into the head, and we can say script, which is the name of the element that runs JavaScript, and we can say source equals and give it a location to a JavaScript file. So we can just say script.js. Okay, and then the script tag, it requires a closing tag, right? So when we load this page, each one, I'll say JavaScript intro, right? When we load this page, our browser is going to attempt to open up, it's going to attempt to load that script just like it does when we load CSS or when we load an image, right? So if we were to watch this, you can see that it tries to load script.js, and it tells us the status is 404. And 404 just means, hey, you told me to request this file, but the file was not found, right? And so if we were to view page source, for example, and click on script.js, it's this type of, we cannot get this resource. That's a 404 error, okay? So this is the first major way to embed JavaScript in our code. Okay, this is kind of an external JavaScript, right? So it's being loaded from another file outside of the program. External JavaScript. And if we wanted to make this work, right, let's say JS I'm going to make a folder here. I'm going to create a file, script.js. And so just in here, I'm going to put alert hello, right? So when I load this page, that's the code that is loaded. And when you view the actual page, it pops up an alert box, right? And it says hello. Now it is showing up as, you know, it was a 200 status. That means, hey, this is an OK request. Here's the resource you looked for, okay? External JavaScript is defined like this. Now, there's another way to embed JavaScript in our code, and that is with the internal version, right? So if I was to use the script tag without a source attribute, right? Without the source attribute, I can say hello world, right? So this is an internal JavaScript. And if we reload this, it says hello, and then it pops up world. You'll notice that by default, it follows the same sorts of rules as most of the other things we've been learning, right? It goes from top to bottom whenever possible, right? So the browser comes in, loads in that script file, and then processes this line of alert, this alert that says hello. If I was to move this up, right, this world is going to pop up first, and then it will alert hello, right? So it says world hello. Oops. World hello. Okay. This is internal. This is external. The cool thing is, this internal, right, this is all happening because we put this in the head. It's happening before the page content is available. And we'll learn about ordering and structure in a little bit, but you'll notice that when I reload this page, this alert, this world, and then it says hello, is showing up before HTML content in here. Do you see this? As soon as I click OK, now the rest of the page is going to render. This is happening before the content has been available. If I was to put this at the bottom, I could put this script tag in the body. Now it is going to, let's reload here. It's still blocking, but now you'll see that JavaScript intro is showing up in the background, you know, kind of in between those buttons. So what is generally happening is that the browser is requesting the resources and processing the document object model, which is this background, the HTML and the content that goes in our page. We cannot guarantee the order of which these things are going to execute. We are going to learn how to control that, but it's important to note that generally when you're embedding JavaScript like this in your page, you can place these script elements wherever you want. It's generally best practice to keep them in the head so that you know, when you're developing products, you know exactly where to look. Sometimes you will come across a product that says, hey, this script, or you'll maybe Google Apps is or Google Analytics or Google Maps is a great example where they'll say, just embed this script tag wherever you need to use it, right? They'll give you the code to paste into your code. And sometimes they'll tell you specifically, put this at the very end of your page so that you can guarantee that the page content will be there to begin with. You just generally have to follow whatever directions are given to you. This script tag can be used anywhere. So let's take out these alerts so they don't keep alerting at us. Good. And good. All right. Any questions about the difference between internal and external? No? Okay. So let's take a look at one of the ways we can control the structure of how, so if I was to put in alert, hello, put full message here, right? Right, this script tag is going to load that file, and if I load this page, as we saw a minute ago, this pop-up is happening before the content of the page is available. We have an attribute that we have available to us here called defer. It just goes by itself, and what that's going to say is load this file, load this JavaScript, but do not start to run it until the rest of the page content has loaded. This is going to be extremely important when we start playing with JavaScript and actually using it to interact with our pages, right? So if I was to run this now, right, the document object is available, even though, yeah, you can see it's available to us before this alert has popped up, right? This is extremely important for one specific, let's see if we can make let's make an example of this. ID header, right? I'm going to write some JavaScript. I don't expect you guys to know this yet, but I'm just trying to show off how this is important, right? So I'm going to say document.getElement by ID header dot style dot background color equals blue, right? And let's pull up our developer toolbar as well so you can see this in action. All right. So if I'm in here and I load this code in my header and I don't have the defer attribute, I don't tell it to defer. When I reload this page, it's going to say type error, cannot read properties of null. And the line that's telling us that is script.js line 3. If we click on it, it takes us right to it. Because document.getElement by ID header is trying to reference this element that does not exist yet. It has not been created. Okay? We used to, in the olden days before there was a defer attribute, we would have to come in here and say, like set timeout, function, put this in a thing that would happen, 500 milliseconds after the page is loaded. Right? This was like the earliest way that we would make our code attached to the page, right? Before the defer attribute came around. Right? So now you can see that when I load this page, it does, it flickers briefly as white, and then it immediately turns blue. There's another way that we could tell it to do this. Let's say, I'm going to create this as a function, turn blue. Document.getElement by ID header dot style dot background color equals blue. Right. So right now, this script that I've written, I put the code to actually make this change into a function. We're going to learn all about functions later on. But what it basically does is this is not going to run until somebody calls this function. Right? I could call this function right here, turn blue. Right? This is me calling the function. And if I was to do this, you're going to get the exact same error we had before. Right? It's saying cannot read properties of null because that element doesn't exist yet. But what I could do from here is that I could come in here into my code. I can say turn blue. Right? Any code that is available to our page is available for us to interact with in our developer console. Right? So if I hit this, it turns blue. Right? I'm calling that thing. The other way that we first got access to control the flow of the programs in our browser is that we have a whole bunch of attributes on the elements themselves. We haven't talked about these elements. We did for some of the inputs, but we have an onload attribute that lets us run JavaScript. Right? So we can say turn blue. And I put this in the body. So I'm saying when the body is done loading, call turn blue. And so now it does. Or we can simply use the newest, most modern way that was really built into the thing and just say defer. And then what we can do is instead of putting in JavaScript code in our HTML elements like this, we can just write whatever code we want in here in our script and know that because we put defer in here, it's going to be loaded once the page has finished all the stuff it needs to be set up. It's going to load the rest of the document before it tries to call this JavaScript. Any question? Or we could have not had defer and put this at the bottom. Right? So now the page will have finished loading before it even gets that script. Same thing. But if you ever start seeing things like this, cannot read properties of null, if you click on the line of code in this thing, it says, secret script.js line 3, it's going to take you directly to the line of code that is broken. If you've written good code, there's only two choices here. Either A, you've got a typo in your element ID or something like that, or you probably forgot to defer. So what I'm going to encourage you to do in this course specifically is to really just get in the habit of whenever you're going to load JavaScript into your pages, right? It's probably just best to put it all the way here at the top, and it's best to write defer. Defer. Any other questions?
Where does DOM come into play?
The DOM in general, we're going to talk about that sometime this week, I believe. DOM stands for Document Object Model. right? And so that's actually behind the scenes when we're looking at this. This is the document object model, right? This is the document, right? It starts at the top of our page, and it's a structured way to describe, using JavaScript, how to interact with these elements, right? So you just saw me use a little bit of the DOM here by saying document.getElementById, which is going to return to us an element, and then I'm going to use the style property of this document and change the background color property to blue. And you'll notice that this says background color. This is literally the exact same as if we'd come in here in our CSS, right? And we did style type equals text/CSS. And define that as this header background color blue. Right? They're doing the exact same thing. The only difference is when we're interacting with the document object model in JavaScript, all of these properties in CSS that have a dash in them, it's replaced with what is known as camel case. Right? So instead of a dash, they separate the words with the second word will be capitalized. Right? So background color. That's how it's done in JavaScript. Any style we want to set in CSS, you can set it in JavaScript under the .style object. This entire thing, we're going to learn about the difference in like structures and data models and things. These are all objects, and so that's why this is called the document object model. It's taking the document, which is our web page, and turning it into a model that we can work on in JavaScript through a series of objects and methods and functions and things. Even like document.getElementById, this is a function that takes an argument of an ID, and it returns that element to us so that we can do stuff with it. Anything that you see me do in the code here, in JavaScript, I want to encourage you to start getting very comfortable having this developer toolbar up, right? This is the most useful tool at your disposal for writing JavaScript, right? So any code that I want to write, I can test in here. Right, I can say document.getElementById, and I can put in header, and you will see that when I hit enter here, it's returning, right? The return value of this function is this h1 that's on our page. If I was to type in something that doesn't exist, right, like ASDF, right, it's returning null. That element does not exist in this page, right? If I return this, I could, and then from here, right, .style is an object that has all of the CSS properties that we may or may not want to set. Can I make this bigger too? Yeah, perfect. Yeah. So it's very useful to have this developer toolbar up all the time. You can write any valid JavaScript code in here and see what the answer is going to be, right? We can do math, right? Like 50 plus 10, 60. Right? If we had complicated code on our page, right, we wrote the turn blue function, right? If I call it, right, if I put parentheses here and hit enter, it's going to actually run that line of code that turns it blue. But if I don't call it and I hit enter, it's going to show me that turn blue is a function with this code inside of it, right? So we can inspect every piece of code that is in a page. And you can see that in the sources tab is here as well, right? This is where it takes us to. This code was loaded by this page. And so it knows to include it in here. And we can even use this, which will, when we get into a little bit more advanced in learning about debugging and stuff, we can set breakpoints and things, right? I can say, hey, stop here. And now when I reload this page, right, you can see that it stopped the execution. It puts paused in debugger, and I'd be able to step through this stuff and see what's actually happening line by line. We'll cover all of this in great detail later. I just want to kind of show, we're going to do like a high level, 50,000 foot view of this, and then zoom on in and learn step by step as we go. So I'm going to resume. Good. Turn off my breakpoint. Any questions? That's how we embed JavaScript in our pages. Internal and external. External is by far the most prevalent. If you're writing a lot of internal code, kind of the same rule applies that we talked about when we were learning CSS, which is, it's sometimes useful to just write a quick script tag to, if you were in here and you're getting ready and you said, I know I want this button to do something, I'm gonna, it's useful to be able to come in here in the code and just say, script type equals text slash JavaScript. You know, write a few lines of code in here, and then once you're happy with the way it works, right, then put it into an external file so that it's nice and neat. These script tags get the added benefit of they're cacheable, right? So when you're building a website for a lot of users, just like with our CSS, if you've got CSS and JavaScript files that are externally defined, those are going to be sent to the user once and then hopefully cached so that the user doesn't have to get them again. And if we were to pull up our network tab, let's see. Right, so index.html and script.js show a status of 200. If I reload this again, now script.js has a status of 304. And what 304 means is this hasn't changed. You don't need to download this again. This is telling our browser, there's been no changes. I don't need to send you this full content anymore. If I was to do a hard reload, which is Control, Shift, and R on Windows, and Command, Shift, and R on Mac, it's going to say, I don't care if you have it cached. I'm hitting Control, Shift, R right now. It's saying, give it to me anyway. And you'll notice that when it does that, it looks for the favicon again. But if I just reload normally, or I click this reload button, every time you go to this page, it's telling us this file hasn't changed. You don't need to get it. And so it's saving a whole bunch of server time and a whole bunch of bandwidth, especially at scale, right, where some of these scripts are going to be pretty big. Cool. Any questions about that? No? All right. JavaScript as a language is fairly small. There is very few specific keywords that you need to memorize and learn, right? A keyword in JavaScript is a special word that does something next. So let's just pull this up as an example. I'm going to search for JavaScript keywords. Yeah, perfect. So this is it. This is this is the entirety of the programming language of JavaScript right here. With this, right, you'll notice this is one of those things that we've been talking about kind of as like a theme over the last couple of weeks, is that once you've learned one programming language, in this case JavaScript, going to another programming language is going to be extremely easy because most of them are very similar, right? These are the same sorts of keywords that you're going to see in PHP or that you're going to see in C++ or C. This is the entirety of the programming language. If you memorized, for example, what is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 16 times 4. If you memorize this, what is that? 64 keywords, you can program anything there is to do in JavaScript. This is all you need. These keywords let you couple things together, right? So like var, for example, where's that at? Var. What always follows the word var is the name of your variable. Same as let. Let is the same as var for the most. We'll learn about that later on. But these two words mean I want to create a variable. And so, it might say var first name equals Eric, okay? But it's always going to be the same. That's always how you create a variable. And so we're going to go through, over the next couple of days, learning about a lot of these keywords and learning about a lot of these reserved words and what they do and how we can use them to build interesting and cool web products. Now, the complexity of JavaScript really comes in learning the document object model, especially on the front end, right? This is the entirety of the programming language. And when we get to be working with Node on the back end, you're going to be using much more of this than you will be when we're working on the front end, because this is the entirety of JavaScript. But as you saw from when we were playing in here, right? Document.getElement by ID, right? There's all these functions that we need to learn so that we can interact with web pages, right? So document.url, document.body, right? That's going to take us right to the body element, right? There's all this stuff that is hidden inside of the objects specific to the browser interface, specific to pages. But the JavaScript language itself is fairly clean and easy to learn. And as long as you're able to know, and hopefully it's my hope that what we'll focus on in this class the most is teaching you the tools so that you can go find out new things. Right? When we start learning about Node, which is just JavaScript but on a server, the language itself is the same. But you'll spend all of your time going to npm.org, right? I think that's here. There are, oh, that's not it. npm.js? Yeah, I'll just click that. Yeah, .com. This is the node package system. So lots of people have created open source JavaScript objects that you can drop into your program. Let's just look at MySQL, for example. Right? There are hundreds and hundreds, if not thousands, of modules for how to connect to a MySQL database. It's all JavaScript, but each one is going to have slightly different syntax. And so you're going to spend all of your time testing things out, reading documentation, right? This is all just JavaScript. You're going to learn this. It's going to be very familiar and comfortable to you. But the secret to being a programmer is being able to ingest documentation and combine what you've learned in new and interesting ways. Cool. Yeah, so the JavaScript keywords, most of the time, like, for example, when we're here, this is a keyword. This is the only keyword in this entire page. This is the name of our function. This is the name of an object in the browser. This is a name of a function that is inside the document object. This is a property of the element that is returned. Okay, so all of these things increase the complexity of programming. The language is simple, but the tooling and the APIs and the interfaces that we interact with are the parts that take trial and error. But luckily, it's much easier now because you have tools like the developer toolbar in the console that let us explore and experiment, right? If I type document in here, you can see that this document object right, has all kinds of things that let us do let's see, document, yeah, you can see, so each of these options in here, right, get element by ID, for example, right, is just one of the functions that is on that object, and we'll be able to explore and figure out how to use these as we go along. Document.location is when we're on a page, the document.location object has all the information about the URL, right? So it says the document.location.href is the full URL of the page, right? And so when we play with this, we can say in here in our JavaScript, document.location.href equals https google.com. And what this is going to do, as soon as I hit enter, the page is going to Google. Anything we can do in a browser, for the most part, you can touch with JavaScript, and that's all this is. We're going to change the things that we've spent time crafting, so we're going to build beautiful websites, we're going to get them styled with CSS, and then with JavaScript, specifically talking about the front end now, is we're going to change the experience for the user when they do things. We're going to make it so that the page is interactive. We're going to download resources from the internet so that we can, display weather information or, communicate with Josh's smoker so that we can get what is the current internal temperature of the thing. We can do all that with JavaScript, and we will. When we're in JavaScript, they have a few different types of comments. As you learned, right, in CSS, right, we comment an entire section by doing a / asterisk, and then an asterisk and another / at the end. This is a multi-line comment, right? So if I was to come in here and say turn blue, turn green, right, all of this would be commented out. Okay. And if I was to use our editor, right, we know that our editor has a nice little feature that helps us out where I can press Control and hit /. It's going to comment them all out. Okay, but it's using the single line comment syntax that we haven't taught you yet. And the single line comment syntax is 2 /. Right? So if I do / here, right, that is now commented out. You'll notice that my thing here turned red, and that's because our editor is smart enough to know the syntax of JavaScript and tell us we're making a mistake here, right? If this line is commented out, function turn blue and the curly bracket, then this curly bracket doesn't have a partner, right? There's no matching pair. A curly bracket needs to be open, and if we were to hover over this, I think, it's going to say declaration or statement expected. It's expecting there to be a curly bracket in the first place. And if I was to put this here, right, now it's good, even though this is an empty curly bracket that does nothing. Because it knows a closing curly bracket needs an opening curly bracket. And if I was to do the same the other way, right, I'd do like this. Okay, now you're going to have an error down here at the end. It's going to say curly bracket expected, right? The parser expected to find a curly bracket to match the open one, and there was none, right? So this is the comment syntax. 2 slashes is single line, slash asterisk is multi-line. And you'll notice, if I was to have some code in here, I put some code down here, right? This is going to go until it finds a closing option. So this is already in a commented off area. And so it's going from here all the way down to the bottom, and it's ignoring this one in the middle. Okay. Any questions about those two commenting types? And remember, it's always useful to remember control plus slash. Just to, wherever you're at, if you just want to comment out that line, control slash will save you a lot of time. All right, let's keep diagnosing or talking about the specifics of JavaScript stuff here, right? So we took a look at this line of code, and we don't really expect you to know all of this, but it shows off a lot of the cool complexity of JavaScript in the context of the document object model, right? So document by itself is an object, right? It has a whole bunch of other things stuffed inside of it. It's got functions, it's got methods, it's got properties, and we can chain all of those together. So we're saying document.getElementById, and you'll notice that this is yellow. It's the same color as our name of our function, because our editor knows this is a method, right? And it's going to tell us, if we hover over it, it's going to say the method document.getElementById expects a string, and it's going to return an HTML element, right? So I could come here and say, right, let's diagnose this. I could say var lm equals document.getElementById header, right? It's perfectly valid code. I'm taking the return of document.getElementById, and I'm putting it in a variable called ELEM, right? Now, I wanted to change this to blue, right? So I can do lm.style, right? Style is a property of the HTML element object, and I'm going to set its property of background color to blue, right? So this is an assignment operator. We're saying this property, CSS style decoration dot background color, is a string, and we're saying, hey, make this value blue. Okay. I could have also come in here and said, var styles equals lm.style. Okay, I'm assigning now lm style to styles, and I can come in here and replace this with styles dot background color blue. Every part of these chains can be broken up into different sections, right? Generally, if I was to do document.getElementById header, right? And let's assign it to EL, right? So EL now is our element, right? If I type it out by itself in our console, I can see that EL is our element. If I do EL.style, right, that's that CSS style decoration, I can do EL.style.background color equals green. Right, now it's green. I can also do anything else that we can do in CSS. I can do el.style.border, and I'll do 1px solid purple. Oop, got my quotes. That's too small. I should have made it bigger. 4px. Yeah, so now I've got a purple border. All the stuff we can do in JavaScript and CSS is capable of being done at the element level in the document with the el.style property. So that is and each of these are properties that exist as a part of an object, right? So style is an object itself, full of that exists inside of every element on the page. Every single element on the page is going to have a style property. If I was to come in here and make a, let's say, h2 id equals subhead second header, right? And we reload our page. Document.getElementById subhead var h2 equals var h1 equals document.getElement the header, right? h1.style is completely different than h2.style, right? h2.style.background color equals green. h1.style.background color equals blue, right? And the cool thing is, as we're updating this information with our JavaScript, right, our page source is the same, right? It just still says h1 header, h2 subhead, whatever. If we were to inspect the elements in here, you'll notice that when we use this the dot style property in JavaScript, it's actually setting, or it's represented here as the attribute style. Right? So we're actually setting these values in here. If I was to come in here, for example, and say, let's make this red now, red. Right? Now it says red. It's the same as if I'd came in here and edited this manually and said, pink. Okay? It's a bunch of different ways to get the same bit of functionality, right? We could have styled this in CSS, which is really the right way to do things for style information. But when we're playing with JavaScript, if we wanted to make, imagine a scenario where you submit a form and you're missing, a required field. You can have JavaScript turn the input color to red and say, hey, this is missing, or whatever. All of that is possible with JavaScript that we're going to learn over the next couple days. Any questions about this? So the other thing that we've kind of touched on, so this get element by ID is known as a method, or in some cases a function, right? Function and method are similar things, right? A function is any piece of code that can be called, that can be executed independently, right? So turn blue is a function because I can come in here and at any time I want say turn blue, right? Turn blue, turn blue. I can call it as many times as I want. It's callable. A method is a function that lives inside of an object, right? So the only difference between get element by ID and turn blue is that they, turn blue is kind of like its own thing. It stands alone. But I could have just as easily created an object called var cool obj, right? This is an object now, and we'll learn about the different syntax. I'll say cool obj neat method function console.log hello, right? So now I have a cool object, right? And the cool object has a function inside of it, neat method, right? And if we just type it by itself, right, it shows us, hey, this is a function. And it uses the F signal symbol here to say, hey, this method calls console.log. If I actually call this, right, it's going to actually console.log and put hello in here. Methods and functions are the exact same thing. Just a method belongs to an object. And technically in JavaScript, all of our functions, right, even our one turn blue, right, for example, where I said this is a function, okay, it exists inside of an object by default. It's under window. So window.turnBlue is a method, right? So function and method, it's kind of a silly anachronism. You'll hear them used interchangeably, so just do not be concerned. I try to use the word method when I mean a function that exists in an object, and I try to use the word function when I mean just a function off on its own. They are literally the exact same thing. We're talking about the same thing. A function or a method is a piece of code that is callable, right? That can be executed. And what callable means is, right, if I type turn blue by itself, right, that is not calling the function. We are calling a function when we include two parentheses. This calls it. And if I was to, what's that other one? Cool, right? It can be called multiple times, right? I can say neat method. I'm calling the neat method function or method as many times as I want. It's going to always do the hello. Okay? This is calling. If I do not include my parentheses, just to show me the code, right? Because this is the value of neat method. The value of neat method is this, this line of code inside curly brackets. The cool thing also is I can say var new function equals cool object dot neat method, right? So cool object dot neat method still exists, but now I've got a new variable called new function that is the same code, and I can call it whenever I want. Okay? We'll dive more into the internals of that later on, because there's a lot of really cool things we can do by stealing functions and changing them a little bit. Any questions about any of this? one last thing to discuss, right? So all of these functions, you'll notice that when we define the function, we're using the keyword function, right? We're doing it in both places. And then we have the name of that function, right? So in this case, it's turn blue. And in this case, it's got a different kind of syntax where it puts the name first because it's in this object. And so it says neat method is the name, and the value of neat method is an anonymous function. So they're both doing the same things, just with slightly different stylistic choices. The second part of this is that when we're defining our functions, we're putting the parentheses up here, followed by curly brackets. So this by itself, right? This is a completely valid function, right? It's got the name function, it's got a name for itself, parentheses, and then curly brackets. Anything in between the curly brackets is what's going to be executed, will be executed when called, right? The other thing that we can do is we can specify arguments, or you'll sometimes hear them called parameters, in the function declaration. So we can say, name, age, right? We can separate these by commas, and what that's going to do is inside this function, when this code is loaded, these variables will be available to us. So I can come in here and say console.log hello plus name, console.log I am happy to see that you are plus age years old. Right? So all I'm simply doing is I'm calling console.log twice, but this is going to change each and every time I call this function. Right? So if I come back into our page here and I say turn blue, Eric, 37. Hello, Eric. I'm happy to see you're 37 years old. If I change this to, Meg, she's like a baby. So, hello, Meg. Right. So this is the power of functions. We can write code that reacts and responds to the arguments that we pass to it. And so document.getElementById is a great example of this, and we're going to use this one all the time. Right? By default, document.getElementById expects us to put in a string. It expects us to put in a name of an element that exists in the page, and it's going to return that to us. If I type in subhead, it returns our H2. This is the basis, this is the foundation of everything we're going to do in JavaScript. We're going to write functions, we're going to write code that does things when a user clicks a button or when someone submits a form. We're going to process all that data, we're going to do interesting things with it, and then we're going to make the world a better place. So that's kind of the structure. Any questions? No? All right. It is 4:50. We've got a lot of content to cover today. Let's take a break. Come back at 5:05. Started? All right, so next, let's look at the structure of JavaScript code. All right, so we've it's important that we all have a shared language, a shared understanding of what these little components and pieces are, so that we can describe what we're trying to do and what's missing, right? So the first thing we're going to talk about a few of these things, right? So when we have these squiggly brackets like this, I call them squiggly brackets often, like that's an old, really bad habit. These are curly brackets. That's their official name for this. So when we talk about, hey, you're missing a curly bracket here, or that you're missing a closed curly bracket, it's these symbols, okay? Square brackets are the ones that don't have a curl in the middle, right? We use these for arrays and things like that in JavaScript. Okay, a tick mark, or sometimes called a back tick, is this. It's like a single quote, but it's the one that is pointed downwards. It is on most people's keyboards directly to the left of the one key, right? So it should be up there, right under the tilde, which is that symbol, tilde. And then, most importantly, is the semicolon, right? We use semicolons in JavaScript to end the current execution of the specific line that we're in, right? It's saying, this statement is finished. It's like a period or an exclamation point. So it's very important to remember the semicolon, and the semicolon key is directly to the right of your L key on your keyboard. And then when we talk about JavaScript coding styles, we're not going to spend too much time in here, but this is what's known as the Egyptian style, right? And the Egyptian style is whenever you've got a function, you put the curly bracket at the end of that line. Okay? Just like with HTML and CSS, JavaScript is extremely forgiving with white space, right? And so putting this curly bracket on the following line is also valid code. stylistically, this would be like, gosh, I don't even know the name of this style, but this is a popular modern style, which is when you write a function, function, some function, right? You put the curly brackets on the line directly below the name function, right? So f and then this. There's no right or wrong answer. When you get into your future employer, they're often going to have a specific coding style or a coding standard, and you'll be expected to follow it. Now, whenever I start a company, I say, hey, our official coding style is the Egyptian style. I always want my curly bracket to be on the same line as the function. But a lot of people, like maybe this is a 50-50 split, prefer it to be on the line below. So don't be surprised if you see it both ways. In this class, whenever possible, use the Egyptian style. The one thing you don't want to do is have a mishmash of styles throughout your code, right? So you don't want to ever have, some of my functions declared this way, some of my functions declared this other way, and then you definitely don't want like random, nonsensical, like pick a style and go with it, right? Because this code, like alert low, is perfectly valid code to JavaScript. JavaScript doesn't care that you added all these extra spaces. Like this will execute just as well as this or this. Now, pick one that you like, stick with it forever. There's no right or wrong answer. I always write it in this style because it's what I grew up doing. This is like the original style that was invented for the C programming language way back in the 60s or whatever. So I've just gotten kind of used to it. And when I see this style, it makes me feel very uncomfortable. For no reason other than it just looks wrong to me. Okay? Those are the two styles there, right? And you can see that there's a curly bracket. Here is parentheses, right? We call these parens or parentheses. All right, let's dive into the JavaScript console. We've been kind of playing with this, right? Over the last little bit while we were exploring what all the cool stuff that we have in JavaScript. The console here is available to us through the console object. And if you just type in console, you can see all of the things that we have available to us in this console, right? So it has all of these methods. You can see these are all methods because they have the little F here and they've got like the name of the thing plus a parenthesis. These are all methods with the exception of memory. Memory is showing you how much actual RAM this browser is taking up here. But the one we use probably most often is console.log. And what log does is it lets us put stuff in the console for us to see it, right? So think of this as like our debugging superpower, right? We can say hello, 5, right? It's going to print out hello and then the number 5. Anything that can be debugged in JavaScript or in anything like that, we can pass it to console.log. So remember we were looking at document earlier and we were saying, hey, when I type on this, right, it shows some of the HTML here. If I was to do console.log document, let's see what happens, right? It's doing that exact same thing. So us typing console.log in there and passing this object in is letting us see all the properties of that, right? What was the one we made? Cool object, right? So if I do console.log cool object, right, you can see that it lets us inspect each of these objects and see what the properties are, see what methods it has in it, right? If it's got any secret methods, right? Like so every function in JavaScript, every method in JavaScript has an arguments option, a caller option, a length, a name. The name is the name property is actually what defines how this function is called. And then it has a prototype that has the actual code itself in here. The console.log is your best friend. We also have, I'll skip table for now. If we wanted it to show up as an error, right, let's write this in here so that it's easy to see. I'm going to clear all this out. Right, so I'm going to do console.log, right? I'm going to show this as an example. And we end our line of code with a semicolon. We also have console.error. This is an error. Console.error, right? And what this will do is that it's going to show up with that red color, right? It's going to say, this is an error. And it also gives us a stack trace. It's going to tell us exactly where this line of code was called. So if you're writing code and you want it to display an error intentionally, you can use console.error, and this will show us how we got there, right? And if I was to go like this here, let's say, let's wrap this in a function. Function call error. Okay. let's put call error here. Right? So we're calling the call error function, which is then going to run console.error. When we look at this, we click this little down arrow, you can see that line 9 was the first thing. It goes in like reverse chronological order. Line 9 called line 5, which was this, which actually threw this error. So it lets us debug and dive deep into why things are happening. Console.error is extremely powerful, right? Because it gives us this stack information. It's called a stack trace. Okay. We also have a console.info. This is console.info. And it's going to look exactly the same as console.log. Okay. But it used to, right? So one of the things, like every once in a while, this is still an ongoing piece of development, right? Each browser is implementing this console object differently. It used to have like a little green indicator. So they just recently changed the style to make it look exactly the same as a regular console.log. But it used to be green or blue. Another one we have, if we wanted to warn, right, we can say this is console.warn, right? This one definitely shows up with a different style. It shows up as a yellow. And it's going to give us the same kind of information that we get from our error, right? It gives us a stack trace. So console.log is kind of the default. Console.info used to be green or blue, but now it's just kind of it's very similar to console.log. Console.warn gives us a yellow one with a stack trace, and console.error gives us a red one with a stack trace, right? So we can control what information is being displayed to our page. If we ever, for whatever reason, wanted to clear this out, right, we also have console.clear, and it's going to give us a little secret message, console was cleared. Or load the page. This is, if you ever needed to clear this for whatever reason, I mean, maybe you put this as the last line of code on your page or something, so that if anyone's looking, if you have debugging information, maybe you just want to clean it out. But this is always available to you in the console as well. So if you need to clean this out, right, console.clear. You can also, if you didn't want to use console.clear, you can click this button right here. This is going to do the same thing, but without that secret message. If I was to come in here, for example, and type console.clear here, right, we're gonna lose those two logging messages, the console.log one and the console.info one, and we're just gonna get the warn and the error, right? Because we've cleared it right here, then we warn, then we call error, which calls that error there. We also have two really cool things, right? So I could come up here and say, right, console.time, and what console.time does is that it starts a timer, okay? And so if I was to come in here and say, what it does is it takes an argument, and the argument it takes is the name of the timer to time, right? So I can say call error, right? Doesn't matter what we put in here. What matters is there is a console.timeEnd function, and if you pass in call error, right, it's going to stop that timer that we just started. It's going to tell you how long it took to run that code. It took call error took 0.06 milliseconds, right? So very, very fast. If you wanted to use, this is extremely useful when you're trying to figure out like performance bottlenecks, right? If we had, let's say, for var I equals 0, I is less than 10,000, I plus plus, right? So this is going to take a little bit of time to loop through this, and we'll just do var equals 0. Num plus I, right? So all I'm doing is I'm looping through. I'm just looping it, 10,000 times, 100,000 times here, and I'm just adding a number. So just something to hopefully delay this out, right? Now you can see this took 1.6 milliseconds, right? So if we were trying to track down performance problems in our code, the time and time end functions or methods of the console object make it very easy for us to track down what is going wrong. Like, so we can come in here and put one, console.time start of app, right? And then I can time end this at the very bottom, right? I can have two timers running, start of app, right? And this, and then once we get to this one, it's starting a new timer called call error, which is just really looking at how long does it take for this function to run. And then we're going to see the result of the entire page, right? So, time end. Yeah. This probably has to all be one word, huh? Start of app. There we go. Timer start of app does not exist. Start of app. Start of app. Maybe it will let us run two at the same time. Let's take these out and see if this works. Or maybe our label is too long. Yeah. It just changes to start. There might be some kind of limit to how big this label can be. Timer start does not exist. What do you mean it doesn't exist? It's right there. You dang liar. Timer start does not exist. What? Test. Let's change the name to test. Oop. Timer test does not exist. What? Oh, console.clear clears the console and deletes the timers. Very tricky. So let's put this back to how it was. And maybe we can show this off a little better. So let's take out our console.clear here. Console.clear is clearing out the entire object. So you can see call error took 1.1 milliseconds and the entire thing took 1.3. So you would obviously expect a timer inside of a timer to be a subset of the total number. Let's see if we can make this more extreme. Make this, it takes 6.8 to run that loop. So the rest of the app runs pretty quickly. So console.time and console.timeend are very powerful. And if you run console.clear inside of a timer, that timer will be deleted. So be aware of that. I've never seen that before in my life. That was fun. Any questions about those? There was another really cool one, and I don't use this often, but it is console.table. And it lets us really display like a table inside of our console. So I've got one kind of created. Right, it takes two arguments. The first is an array of objects. Right, so in this one it says Ford, Mustang, Chevy, Camaro, and then it has the so make and model. Right, so this is showing us this is kind of the table display. It gives us a nice looking little table here. So if we wanted to display a large data set for some reason, and the JavaScript console was where we wanted to do it, then we could do it with the console.table function. The console function is probably the single best development in web development in the last 20 years. Like, hands down. JavaScript used to be super duper painful in the early thousands to try and figure out what was going on. We used to literally, before console existed, we would literally go in here and put alert things all over the place. We would say like alert var name equals Eric, right? We would do alert name is plus name, right? Just so we could see inside. Unexpected token. No, so we could see inside of our code. Right? This was the only way we can inspect what was happening behind the scenes in our JavaScript programs before we got a developer console like this. This revolutionized web development and made it so that this was an actual pleasant place to do coding rather than a painful place. The console object is your best friend. Any questions? Like Reef?
Why would we use the table again?
The console to display a table of information. This is one of the newer ones. They're adding stuff in here to like give us stylistic options to display our information. So if you had a table of data that you wanted to display in your console for some reason, you could do that here. I've never needed to use it for anything real, but it's there as an option.
But it doesn't affect the actual web page, though, right?
Yeah, it's everything in the console object is just for inside this development console. This right here.
Got it.
Any other questions? Everyone gets it? There's like something wrong with my Diet Coke. It smells like chemicals. I'm not going to drink it. It's really weird. But if I get violently sick, blame the Diet Coke. Alright. Let's talk about variables. We've been playing with this a little bit, just kind of offhand. Variables are how we store our information, right? And we're going to learn about all the different types of information that can be put into variables in a little bit. But it's really important first to learn, like, this is the declaration format, right, for this, okay? So it always starts with a var keyword or other keywords that we're going to learn later on when we get into more modern JavaScript. But the var keyword says, hey, the thing that comes after var is the name of a variable, and I want you to create this as a variable. Think of variables as like buckets or boxes. You can put anything you want in that box. We're just saying this is box 1, this is box 2, this is box 3. So I can refer to it and say, hey, can you give me box 2, please? Right? That is the purpose of variables, and that's what we use them for in each and every programming language. They always start in JavaScript with the var keyword for now. Then there's the concept of declaration, right? When we say var name is declaring a variable called name. Okay, that's a declaration. We can write this by itself, and name will exist even if we don't have a value in it. Okay, we can make another variable. We can say var favorite color. Right? This is declaring a variable called favorite color. Okay, the second part of this, and this is how you'll most often see this used, is that we do our variable declaration and assignment at the same time. Right? So we will often say favorite color equals blue. Right? And we'll say favorite color equals blue. Now, we can go in and say favorite color is now orange. Right? We are assigning the value of orange to favorite color. We do not have to declare it again. Now, JavaScript is very forgiving. If I was to type var favorite color equals orange now, it's not going to throw any errors, or it shouldn't anyway. Yep, everything's good. Because JavaScript doesn't really care that much. But this would be bad coding practice. Okay? Generally, if you declare a variable one time and you use it over and over again, right? And we kind of did this up here, right? We said for var I, which is kind of a shorthand here for an index, equals 0. We're doing it all in one line. Oop. Then we're saying while I is less than 10 million, and then increment I. Right? And we did the same with num. We said var num equals 0. These are all examples of variable declarations. And you'll notice var favorite color is a string, right? It has quotation marks, and I'm saying the word blue goes in favorite color. So if I was to save this right now, right, Control S, and I say, favorite color, right now it says orange because that was the line that executed after we declared it. Okay, if I ran type of favorite color, it's going to tell us that what's in there right now is string, right? It's a string that is in there. Is num available here? No. Right? Let's put this out here, right? So num, right? Type of num is a number, right? A variable can be a number, it can be a string, it can be an object. We're going to learn about all these things. It can even be a function, right? If I did type of, what was the other? Cool object. What are they called? Oh, I deleted it. So type of is an interesting keyword that tells us the type of information that is inside of the variable, right? And so if I was to create a new variable like var some obj equals, right? I'm just going to create an empty object. Type of some obj is an object, right? Variables can contain any type of data that we want to use in JavaScript, right? Now I can take some obj, right, which is currently an object, and I can say some obj now equals 5 or 6. Right? And so now type of some obj is number. There are no guardrails here on what you can or cannot do with your JavaScript, which is why it's very important, and I'm going to keep harping on this as often as possible, that programming is an exercise in expressing yourself, not to the computer, but to other programmers. Because I have a variable here called some obj that is actually currently storing a number, right? That's not clear to anyone. So what we name our variables is the most important thing of being a software engineer. Full stop. The names of variables, the names of objects, the names of functions is the entirety of the job that we're doing. We're trying to communicate our intentions to the computer for the benefit of other programmers, whether it's you by yourself reading your code a week later being like, oh yeah, I remember exactly what I was doing here, because you've named your variables correctly. You've picked names that make sense, that provide value, that make it clear what your intentions were. I could literally write code. Here's an example. We'll do CW equals console.warn, right? Right. So I have just taken console.warn and I created it into a variable called CW, right? So if I come in here and I say CW hi, right? It's doing console.warn. But if you had to read a whole bunch of code that said CW this and CW that, what does CW mean? I don't know. But console.warn is very clear that it's the console object and we are warning with a function. So we're going to use all of our experience as software engineers and as developers to write code that makes it clear to other people what it is we're trying to accomplish. So variable names is probably the most important part of the job. That doesn't mean you should go crazy, right? Java is particularly, the formal Java language that was invented by Sun Microsystems is extremely bad at this. You know, their way of naming things is that it'll be like first name taken from the input field, right? You'll spend literally all day typing out words to just like use variables that they like to have in their language, right? There's a fine balance between being descriptive with the names of our variables and being ridiculously descriptive, right? This is overkill, right, to me. There might be a good reason to use something this long and complex as your variable name, but most of the time you can get away with just first name. It doesn't matter what we choose to name our variables other than is it clear what your intentions are? Is it clear what you're trying to accomplish? Cool. In terms of variable names, you'll see this come up pretty often, but generally in JavaScript, the best practice is to name it with, if you're going to have two words, you're going to have lowercase first word and uppercase second word and third word, right? So first name from input field, right? This is called camel case. Remember that. This is lower camel case. There is another style called upper camel case where you would have every word capitalized. This is upper camel case. Lower camel case is like this. You will see both. There is nothing preventing you from writing any other code, right? We can do first name from input, right? This is also valid code, just less clear what you're trying to do. Unfortunately, because the dash is used in JavaScript as the minus sign, right? You can't do dashed variables like you do in JavaScript, or in CSS, right? So in CSS, you might say, background dash color, okay? To JavaScript, it's trying to say, you want to subtract color from background. That's what it's trying to process when you do this. So there's no dashes in your names in JavaScript. So, in general, JavaScript as a language has said, hey, we're just going to lower camel case everything. So if there was ever a dash in CSS, we're going to use a lower camel case. So it generally makes most sense to lower camel case your variables as well, so that the code looks consistent. You're going to be using lower camel case code all over the place to change background color and stuff like that in JavaScript. So I have always found it nicest to just try and use lower camel case whenever possible in the rest of your code. Now, that also means that if I was making, var name, right? If there's no two words there, I can have a lowercase variable name, right? Nice and easy, and short and sweet. Var last, right? If I wanted it to be last name, if I wanted to be very clear what this is about, I would put in a second word, and I would generally make it lower camel case. There's no, it's no right or wrong answer. You can name your variables whatever you want. You also have the ability to use the $sign in here. Okay, so if for whatever reason you wanted to use a $sign, oftentimes you'll see $sign associated with the jQuery library. jQuery made this very popular because they created a $sign variable as a function, right? That did everything in that library. So they would basically write, selector. And so whatever selector you passed into the $sign argument, generally would do a bunch of jQuery magic, but would always return document.getElementById selector, right? So instead of writing document.getElementById all over the place, you would, just write like header. Right? That would be the same as document.getElementById. This is $sign. It's generally not a good idea in today's web environment to use $ by itself anymore, because so many products and so many websites rely on jQuery to be like the basis of their stuff. So if you were to write a function called $, chances are your library might break if they ever installed jQuery, right? Because jQuery's probably been installed on like 50% of all websites on the planet, right? So always be cautious of using $ by itself. But what I will often do, if I'm writing a library for myself, I might make a little helper function that's like getL, right? Or maybe I'll call it $L. And now I've got a little shorthand version of my own where I can say L header equals, it's going to be the same as returning document.getElement by ID. So I could do L.style.background color equals blue. And if we were to look at our code now, yeah, it goes back to being blue. You can write any kind of function you want to encapsulate multiple lines. Like this one just does one line of code, but there could be a bunch of other stuff, right? We could do something like this. Var L equals document.getElement by ID, the selector that we put in here. Then I could say L dot border, or L dot style dot border bottom equals it's the 3px solid black, right? Return L, right? So we can encapsulate all kinds of magic ourselves in functions that we write, right? If we know we want to have any element we ever get with this the $L function, we want it to we want it to automatically apply a border bottom here. So as if I do L, what do we call it? Head, subhead, right? Oh, I called it L. Oops. You see that it automatically applied that border to it and returned the element to me. Right, so we can do all kinds of cool chaining stuff with our code that we write ourselves. So $ is valid in our variable names. The other thing that is valid in our variable names, so this is another style, is people will use underscores to separate words, right? So they can do name, last name, bar, first name. Perfectly acceptable style. The only thing I will continue to harp on is just whatever version of variable names you want to make, pick one and stick with it. If you want to separate your words with underscore, by all means, knock yourself out. If you like the way that looks, go crazy. But just be consistent, right? Don't have last name and first name like that and use it in the same product. I guarantee you will do stuff like this for the rest of your career, and then you'll get mad at yourself every time you do it. I still do it, and you'll probably catch me doing it in this class, where I'll forget the name of a variable I literally just wrote because I didn't follow, some kind of consistent rule. Because you'll be in here, you'll write this line of code, then you'll go do some stuff on a different page, and then you'll go to a different script file, and then you'll be like, what was the name? Why isn't it working? Oh, because I used an underscore for last name instead of the same thing I used everywhere else. Consistency is going to save you a ton of time and energy if you can get in the habit now. Start practicing that muscle memory of, this is how I name my variables, this is what they're always going to be, this is the rule. Like, create a rule set for yourself that you always will apply to everything. So $ and underscore are really the only two special characters that are allowed in the names of variables. Okay, you cannot use a dot, because a dot is dotted object notation, so it's going to be the same as if it said last was an object that had a dot name property. You can't use a dash because it's a minus. You can't use a plus sign because it's an addition. Right? So all we have is $ and underscore available to us. And then letters. Or you can also use numbers as well. So you can be like last name 1, for example. I don't believe you can create... Yeah, you cannot start a variable with a number. So if you want to use a number in your variable for some reason, you can do that. You just can't begin it with a number. Any questions? All right, chugging on. We already talked about variable declaration and assignment in one line, right? That's kind of the default pattern most of the time. If we were to let's say num is nothing, right? If we come into our page here, right, we just type in num, right? By default, it's giving us not a number, because inside of our loop call error, right, we're calling this, it's saying number equals number plus 1 over and over and over again. But number doesn't have a value in it yet. Right? Number is blank. Right? So let's see. Var new num. Let's declare. And we say new num plus equals new num plus 1. Right? So you cannot do addition, right, plus 1 to something that is not a number. Right? So when we were defining this, we said new num equals 0. Now when we do new num plus 1, it works correctly. So it's important. It's a really good habit to get in, so you don't catch these types of bugs later on when you're assuming. If I was to go in here and say console.log num, right? We're thinking here. Let's make this 100, right? We think that we're going to log out a number here, but what's really happened is we logged out not a number 100 times, right? Because we did not instantiate this to be a number in the first place. And so now this works like we'd expect. It's going to console.log out that number as it grows. So I have always found it to be beneficial that just by default, this is my personal belief, right? Whenever I'm creating a variable like this, I'm going to probably put something in it, right? If I'm going to declare a variable, I'm going to assign it at the same time. There are very, very few instances where I'm declaring a variable and not doing anything with it. Like, why even bother? I'm going to wait till the first time I need to use it. Like, I would have maybe done it down here or someplace. But you can. And lots of people like to declare. So it used to be like best practice that you would like at the start of your code. And some languages this is still preferred, right? You would declare all your variables up here. You'd say, I'm going to use num in here. I'm going to use CW. I'm going to use last name, first name. What else are we using? I, right? So all the variables we're going to use in this entire script, we're going to declare at the top, and then we're going to come through here and use them throughout our script. This is like a very old-fashioned way of programming. But some languages prefer this kind of thing. So there's no right or wrong answer here either. It's just you got really pick a style and stick with it, and know why you're doing it so that you can defend that argument and prevent errors. We already talked about the importance of variable names quite a bit. And we showed that we can change the type of a variable just by assigning a new value to it at any time. JavaScript is a very friendly language. It's called not type safe, right? So some languages will say, hey, you declare your variable with the type of it, right? So this would be like a type safe language like C or C++. For those of you who've experienced this or have seen this before, you would come in here and say int age equals 35, right? The only thing I could store in an int age variable here would be a number, an integer number. So 25.5 is an invalid integer as a double or a float. JavaScript doesn't care about any of that, right? JavaScript is like, yeah, whatever. Our variables are just boxes you can stuff stuff in, right? So the var keyword lets us just say, hey, age is 25.5. Well, that's a number. Age is 25. That's a number. Age is 25. That's a string with a number inside of it, right? JavaScript doesn't care, so it makes it very easy to not worry about those kind of details until they start causing you problems later. And we'll see some of those for sure. Cool. We've kind of already taken a look at it. We've been talking about this already. Right? So we know that there's a type of keyword. Right? The type of keyword will tell us the type of the information stored inside a variable. Right? So type of a number is number. Right? So let's just play with this together. Type of 5 is a number. Type of, we put in Eric. Right? This is going to be a string. Right? A string can be a single quote. It can be double quote. Right? Still a string. Why would you use double quotes instead of single quotes? Any ideas? Any theories? What if I wanted to store Eric's house in here? ERIC''S. to me, that's one of the biggest benefits, is that I can use apostrophes in my strings. We can use it in here, but we'd have to escape it. So there's an escape character that says it's a backslash. And so if I wanted to use a single quote inside of a string that has single quotes on the outsides, we can escape it. And the same is true here, right? If I wanted to use a double quote for, Eric's house is cool, right? I could escape the double quotes as well. So I generally, just by default, I try to use single quotes unless I, just in terms of pure consistency for all of the strings I'm writing myself. Right, like 3px solid black, blue, start of app, console.log. I try to use single quote as my go-to. Plus, it helps that I don't have to hit shift to do it. Right, I can just smash this single quote with my pinky, and I'm off and running. Right, a little bit more efficient for me to type. I'm only generally going to use double quotes when I know, hey, I'm going to write, and you'll still catch me up, but I'm not thinking ahead of what I'm going to write, and so I'll say stuff like, or place name equals Eric's house, and I'll make myself angry. I'll finish it off with a double quote, and I'll go back and fix. Right, you'll catch me do that all the time. Any questions about that? Okay. Boolean. What is a Boolean? Does anyone know what a Boolean is? Go ahead.
Is it like if and then kind of?
Very close. You're definitely on the right track. Boolean just means true or false. True or false. And we're going to use Boolean logic specifically in our if-thens and if-elses, right? So we're checking the true or falseness of a statement, right? So an example of a Boolean, right, is true, right? I can just type the word true, or I can type the word false. If I type of true, well, it's going to show up as object here, but it is a Boolean property, right? And so if, to use your example, true equals 1, right, like console.log true, right? And it's going to say true, because true and 1 are synonyms. 1 is a truthful value, okay? 0 is a false value, right? Behind the scenes, it's really just an on or off. This is the fundamental basis of all computing. It's a 1 or a 0, a true or a false. So in JavaScript, they follow that same kind of logic, right? So we can also do, let's see, do Boolean, right? I created a variable called t, and I put in a Boolean object, right? So that's what the true is, right? When we say type of t, it's saying it's an object because that object that it is a Boolean default thing, right? So if we look at t, right now it's showing up as false, right? Saying that it's a prototype of the Boolean object. Everything in JavaScript from top to bottom, even if it's a string, even if it's a number, even if it's an object, it's all objects. And you can tell this because we're going to write objects ourselves, right? So even string, for example, right? Like a string is an object that has a whole bunch of methods and properties in it, right? Even if you can't see them. A string dot length is a property of the string object that says, hey, this is 8 letters long. 1, 2, 3, 4, 6, 7, 8, right? String dot to locale uppercase, right? So we can locale uppercase, right? Is a function. And I can transform this string into an uppercase string. Same with numbers, right? So 5. 5 dot to degree to rad, right? Degree to rad. Oh, yeah, there's number. Prototype. Right, so numbers by default have a value, right? That's the primitive value, but then it has a value of a toString, a toPrecision, a toFixed, like all these properties and objects that are there behind the scenes on all these types of data. And we'll definitely explore this in greater detail much longer. But Boolean is, just think of Boolean as true or false. Number is any number, right? In some languages, a number in C or C++ or some of these typed languages, right? They break number down in integer versus like doubles and floats. A floating point number is a number that has decimal points, right? So 1.5 is a floating point number. And 5 is an integer. In JavaScript, they don't make any of those distinctions. They just say this is a number, right? So it can be a integer or it can be a floating point number. Then there's a couple special type of objects, right? We saw one already, right? We did var num, okay, num plus 5, right? This is, NaN stands for not a number. You're going to see this whenever you try to do math with a number object against another object that is not a number, right? And so that's what it's telling you here, right? So it's saying that num plus 5 equals not a number. This is a special type of object, and not a number, right? If you type it out, right, is an object itself. And if we do prototype, do like a two-string maybe, yeah. Right? So this itself is an object as well, right? Everything in JavaScript from top to bottom is an object of some kind. There's also null, right, which is another special type of object that means this has no value. Null means this has no value intentionally, right? So if I was to come in here and say var num equals null, right? What we're saying is that this is a value that we have intentionally made to have no value, right? So you're going to see null in lots of programming languages as a way to say this currently means nothing, and we can check that, right? We can say if num equals null. All right, let's just do this way, right? And say num equals null, right? That's going to be true. We're saying the current value of num is null. That is a yes. And if we were to put num to be, num equals 5, right? Checking to see if it's null. Now it says it's false. And then undefined is for anything. This is another type, right? Undefined is another special value for JavaScript, and you'll see this pretty often when you try to reference something that doesn't exist, right? So we've been playing with num, right? Num equals null, right? Or when num was not a number, or when we just declared, first name, right? First name is undefined. It has no value, but that's because it has never been set. It is different from being null. Does that make sense? Null means I've intentionally set a value to be nothing. Undefined means I haven't set a value in the first place. And sometimes you'll see undefined used as it's like the answer to a type error, right? So we did, I'm going to use our EL function here. Let's see, subhead, right? Subhead returns an element to us, right? Our H2 up here. If I did subhead 2, right, cannot read properties of null, right? Because document.getElementById in this line of code is trying to set .style on something that doesn't exist. So when you try to access a property of an undefined value, the entire purpose of the undefined object is to throw these warnings to us, to say, hey, you tried to set a value to something that doesn't exist. That's the whole point of it. And then the most important thing is object. Object, if you think of it from let's actually look at this with it, right? So an object, by default, is just a variable, right? Object that has properties. So we're going to use objects all over the place, right? An object begins with a curly bracket, ends with a curly bracket, and inside of it is named key value pairs, right? So I can say first name colon, dang it, I typed enter, Eric, comma, should write this code in the right? Last name Harrison, right? I can put functions in here. I can say say hi function console.log hi plus this dot first name plus this dot last name. Okay. Where did I have unexpected token? What? Unexpected token. Where do you see that? Oh, I forgot to put a. Yep, forgot my curly bracket. So object is an object, right? And it looks very similar to the ones that we've been looking at today, right? Object has 3 properties here: first name, last name, and say hi. Say hi is a method because it is a function inside of an object, right? So if I say obj.sayHi and I call it, it's going to say hi Eric Harrison. because it has, I use the this, right? This is a reference to the current object that it belongs to. And we'll learn all about that later on. But object is the most fundamental building block of all of JavaScript. We've seen that numbers, right, like 5, has a bunch of properties. It has, a toString, 500.toString, right? That didn't work. Okay, what is some properties that you can use on numbers? Fixed. That would only work for this. Anyway, trying to think of an example. Anyway, let's move on. Everything in JavaScript is an object and can be overwritten, right? So we could say number dot prototype dot to say hi equals function, and we'll say console dot log something neat, right? And so by putting this on the prototype of numbers, right, now then every new number, right, var new num equals 10, right? New num is a type of number. New num is a type of number. So now new num has a thing that says say hi. Right? We've added a function to literally every number in the entirety of our page. Right? This is one of the coolest and most powerful things of all of JavaScript. And every library, well, a large portion of the libraries that you're going to use are going to take advantage of this capability by making it so that, if you're building a video game, for example, and you're using JavaScript, they're going to add a whole bunch of video game specific mathematics to your objects, to your numbers. So you could say, hey, I need to do a matrix multiplication on this array of numbers, right? So they'll say, if there's an array, add this function to it, and it will automatically turn it into the correct 3D transform that you need to do, like to render a panel or something. This is the coolest part of JavaScript, and it's probably, I think, one of the most powerful language features in any modern programming language. C++ has some of this stuff too, but their version is way harder to work with, right? With literally one line of code, we're able to add new functionality to primitive native types of information that every other thing can have. It's really cool. Any questions? We've looked at most of the data types, and we will probably we will definitely spend a lot more time talking about this over the next couple of months, because oftentimes most of our bugs as engineers come in when we mix and match data types like this. Like we tried to add a number to a string, right? Like 5 plus 5, right? It kind of looks like it worked. It gave us the number 55, right? But that's not really what 5 plus 5 is supposed to be, right? It's supposed to be 10. And so fixing a lot of those types of bugs that come up is like, I don't know, it's like 80% of programming is you've got some kind of mismatch between the types of things that you're trying to do. Like a great example of that, right? If we go to let's add an input in here. Let's say input type equals text, name equals age, ID equals age, placeholder equals your age, right? So with JavaScript, right, we've got this age in here, and if I put in 37, if I do document.getElementById age.value, that's how we get the value of an input, right? It's saying 37, which is correct, right? This is 37. But the problem is, this is the string 37. Okay, so if I was to say, all right, var my age equals document.getElementById age.value, right? I got that, and I put it into my age. My age is now, my age is 37. If I wanted to say, my age next year is going to be my age plus 1, right? It literally added the string 1 to the end of the string 37. And so we have to fix these types of problems all the time as developers, and we have to be aware that they exist in the first place. So what we probably wanted to do instead was say that my age equals parse int, which is a function, and I want to pass parse int into my age. Right? So now if I do my age plus 1, it is 38. We're saying parse this string for any integer you find. So we have to do some conversions and things like that. Any questions? I'm throwing a lot at you. I want you to absorb some of this because if there are questions, it's probably everybody has those questions. Go ahead, Josh.
So for that last example, that parse int is just, you said, a function that's literally just taking that string value and converting it into an actual number value or a number.
Yeah, parse int is actually really cool. It takes any string and it looks for a number inside of it, right? So if I had my age is 37, right? Came back with not a number. Must have put in too big of a string. Like M37. I guess it doesn't work like it used to. So what it does is it converts it to an integer, right? It also has the ability to choose if we put in a second one. This is an optional argument, but it's like radix. And so if I put in like 16, right, it's converting it to that base, right? So that would be like hexadecimal. Or if I did what's another one? Octal, right? All right, so if you ever need to convert to a different type of, well, let's do 255. Right, so the radix, if we go to here, W3 Schools has pretty good examples of this. So parse int. Yeah, so the radix is if you wanted to put in hexadecimal values and things. So that's for the parsing. That was what I got backwards. So if I was, right, so we know that like 255, for example, is, or we could do like 0x ff, right? Like that sort of thing. Like we can have parse int parse that value out with that in mind. There's also a parse float, right? So parse int is for integers, right? If I put in 55.5, right, it's going to return just the integer part, 55. If I needed the full value, parse float is going to give us 55.5, so that we can do correct math on it. And we're gonna go over these functions quite a bit later because they're really, really useful, and we use them all the time. Specifically because every input in JavaScript or in HTML is treated as a string. Right? This is a text box. Right? So it's right there in the name. We're putting in text. So if we want to use it as a number, we have to convert it to a number. Cool. I think that's a good stopping point for now. When we come back, we're going to learn a little bit more about strings and stuff. Yeah, we're on good progress. So it's 6:01. Let's come back at 6:15. All right, so we spoke a little bit about type conversion when we were showing off the examples of parse int and parse float. But this works in a couple of different ways as well, right? So, 55, for example, is a number, but it has a toString method. String 55. Oh, it's capital S. String 55. That will let us turn a number into a string. Okay. We can also, there's a shortcut way of doing this. If we do 55 plus and we put an empty string in here, it turns it into a string. So whenever, one of the things that's kind of cool about JavaScript is that it is so flexible like this. And what's going to cause us frustration on one day is going to provide a lot of value another day, right? And so because the DOM, because our HTML, our pages, the document object model, is inherently a structure of strings, right? We're displaying text on a page. The fact that we can take numbers, which are like actual real-world things, and put them in our HTML pages is doing this type of conversion behind the scenes natively all the time. This also works with data structures like arrays, which we haven't learned about yet, but let's make an array. R equals 1, 2, 3, right? So this is an array, and it contains 4 elements, 1, 2, 3, 4. But we can also do r.toString, right? And it's going to turn it into a string-based representation of those elements, right? So type conversion, right, works in a bunch of different types of ways. Type coercion is the thing that is going to cause us probably the most frustration when it happens unexpectedly. And the example of that is when we took the value of this this thing here, right? Right. Let's say I had a number var decade equals 10, right? So I have 10 years in a decade, and I say how much older will I be in a decade? And if I just assumed that I could do decade, let's see, decade plus document dot get element by ID age dot value, right? It's putting 1037 because it added those two together. That's called type coercion. It's added them together. It's made the values work in a way that it can add them together in the style that it knows. It has coerced into a string because it's easier for the interpreter to know that this, like, it knows that it's a string, and it does not know that there is a number in there, but it knows that a number can become a string just by adding quotes. So this is type coercion. And it's very important to be aware that this is happening, so that you don't this. This is a pretty extreme example where you add 10 to 37 and it turns into 1037 as a string. But this can get you caught up very subtly when you don't notice this is happening with numbers that are hard to tell apart, right? If we had like something like this plus like 3, 2, right? That looks like maybe that looks correct, right? It's a big number plus a small number. I'm not sure if that's accurate or not. And so these kinds of problems can find their way into your programs pretty insidiously in a way that's tough to be aware of. Does anyone have any questions about the default types here? We've talked about string. One last thing to note, right? So we have number, right? Numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So this is a number. There is a limit to how big these numbers can be, right? So let's just see how far we can go. Right, 6, 7, 8, 9, 10. Right, you'll notice that it starts going e plus 25 because it's trying to display the fact that this number is very large. So if we were to go in here and say var num equals, let's paste in this whole big thing. If we look at num now, right, it's this large number, right? If we do type of num, it says it's a number. If we kept putting numbers in here, right, eventually we'll run out of space entirely. 3, 4, 6, 7, 8, 9, 10. Good? Num? Right, it's converting this in a way that we can, num equals num plus, right? There's another type that will let us store big numbers like this safely, and that is big int, right? So if I was to put this number in here, big int, right, it changes it into 1, 2, 3, 4, 5, 6, 7 on 5, 2, right? This is the upper limit for how big this number can be. So you have to be very cautious when you're working with large numbers to pick the right type. By default, everything is a number, and that's mostly going to be safe for almost every use case that you have that you might need to do. But one of the examples, and the reason I bring this up now, is that we were doing interview preparation in the last cohort, and we had one of our algorithms that we were trying to write ended up with us working with very large numbers that exceeded the size of the number variable that it can store. And so we had to go and look up that there is a big int type that lets us put in really big numbers and actually do stuff with them mathematically. Okay. Those types of issues don't come up very often in web development. You're very rarely going to come across problems where you need to store super large numbers like that. But it does happen occasionally, and when it does happen, it causes your code to silently break. Like, there would be nothing wrong with the code we wrote, it just wouldn't have the right answer when we're doing the algorithm stuff. So those types of things, just be aware that there are limitations to the size of information you can store in certain types of variables. Cool. So let's look at a few of these. There's a few different types of JavaScript pop-up. Now it's important to note we were showing this off when we were first introducing JavaScript earlier today. We were using the alert method, right? So if I do alert in here and I say hello, right, it's going to pop up a box that says hello. Now, the three things that we're going to show off today are deprecated. And what deprecated means is at some point in the future, they're probably going to stop working. They're being taken out of the JavaScript language. They are not deprecated. They're not out yet. We can still use them. They're an important tool to be able to describe blocking and non-blocking behaviors. And we'll describe that in a second. But it's important, this is where we came from. Okay, so, for 30 years, alert, confirm, prompt, which we're going to show off here, were the way to get, things to pop up. Okay, so we're going to show this off. So alert is how we can make a pop-up box with just an OK box, right? So hello, right? Anytime we type alert, it pops up a box. It's important to note that all three of these are blocking functions. That means I cannot do anything else on this page. Nothing, no other JavaScript code will execute until I click OK. If you ever need to build something that stops all execution, a great example for this is we would use this for a confirmation box, and we would say, are you sure you want to delete this? Yes or no? And we would use the confirm prompt. Confirm. Do you want to delete this? Right? Nothing else will execute until you press OK or cancel. And the important part here is if I click cancel, that is counted as a false value. Right? We were talking about Boolean logic a little bit earlier. I could say if confirm delete this, right? I'm putting this in an if box, and so I'm going to put console.warn you deleted. Right? So what this is saying, we're going to learn about if blocks a little bit later, but this is saying if when this confirm function returns either a true or false based on if I click yes or no. So if I click OK, it's going to say you deleted. If I run this again and I say cancel, that's a false value and it does not say you deleted, right? That has helped us by blocking the rest of the execution so that we can prevent an action, right? You can imagine if I said, if we had confirm delete this, you delete it, and it was actually some code that deletes something, right? Does something permanent. This is preventing this line of code from running until we say yes or no. That's what's called blocking. So that is the confirm option. You'll notice that confirm looks very similar to the alert, right? This is confirm. It has an OK and a cancel. Alert just has an OK. Right? Just has OK. There's no true or false option there. It's just always going to be yes. And then the final one, and this is one that we used to use pretty often for passwords and stuff like that, is prompt. Right? And I can say, please enter your name. And it's going to pop up a little text box like this. And if I put words in here, right, Eric, the return of the prompt function is whatever the user types in here, right? So I could say var first name equals prompt. Please enter your name. Okay. Now let's say I'm Steve now. Okay. First name, the first name variable, if we type this in here, first name, now has Steve in it. And this is another example of, you'll notice that just like with the input, it puts it in a string, right? So if I said prompt, please enter your age, right? And I put in, 37 in here, right? First name, even though it's a terribly named variable here, first name, is the string 37. Everyone following along? If I wanted to change this string 37, if I wanted to change, let's just make this age, var age equals first name. If I wanted to make age, which right now has the string 37, if I wanted to make this an integer, how would I do that? What function would I use to turn this into an integer? Who remembers? Everybody's looking away to not make eye contact. I love it. Go ahead, Josh.
Is it the parse int?
Yeah, parse int. Right? Right, so if I do parse int age, now we get the number 37. Perfect. These three functions were like the backbone of interactive web development in like the late 90s and early thousands, right? We use these all the time. And you still will see like the prompt be used on some older devices. Maybe you log into a router or a switch at your house, and it will pop up a box saying like, please enter your username. Then it'll pop up another one that says, please enter your password, because this used to be the primary method to like get stuff from the user into JavaScript. And we used to use alerts all the time for debugging, right? Before we had a console, if I wanted to see what the value of a variable was, this was pretty much my only way to do it, was by alerting it out and then say like, what is in age right now? Alert age, right? Oh, it's currently 37. And you would see alerts sprinkled throughout your code while you were developing. You'd come in here and say alert, place name, while you try and track down and figure out what the problem was with your code. The other cool thing is, because these are blocking, if we had some kind of problem, imagine this was hundreds of lines long, right? If I had some kind of problem in here, I could alert at a bunch of different times. Let's say, alert num, right? I could verify that my code was working at each step of the way. Okay, you can see here, there's a perfect example. It's alerting not a number over and over and over again in my loop because of that problem that we were talking about earlier, where I did not define num to be a number, right? So that's the kind of thing that you can debug with alert, back when that was the main way to debug things. Let's take that out so it doesn't keep doing it. It's annoying. It used to be very painful to debug JavaScript in the early days. Any questions about alert, prompt, or confirm? I don't know when or if these will actually stop working. They've been deprecated for a couple of years now. There is so much code that still probably exists on the internet using these three things that I'm not sure it will ever go away, or formally out of being a part of the language. But just be aware that it is technically deprecated. And if we went in MSDN, what was it? No, it's alert deprecated. Just for that. Yeah. So this is like the original proposal. And the whole reason is they're trying to, because those are blocking, they're preventing you from being able to sometimes leave web pages, right? I'm sure you guys have seen things where it's like, it pops up and says, are you sure you want to leave this page? Well, some bad pages are saying that over and over and over again, so you can never leave, right? There's, they're kind of nasty. They can be nasty. Cool. Let's talk about math. Math is something that is built in to the language through a couple of different ways. Okay, so natively, right? I'm sure we've kind of seen this as examples we've been playing with all day, right? So let's say we have a number equals 1, right? Num plus 1 equals 2. Num plus 5 equals 6. Right? We can also do a subtraction or a multiplication. Num equals num plus 2 times 6, 5. So now num is 11, right? We can also do division. Num divided by 2, 5.5. 11 divided by 2 is 5.5. Multiplication, if we ever needed, and the multiplication symbol, for example, is the asterisk star. So shift 8 is multiplication. If we ever, right, so num divided by 2 is 5.5. What if I wanted to get the remainder? Does anyone have any idea of how we would do that? There's a special operator, and you're just going to have to know the name of this. It's one of those few things that you just have to memorize. It's called modulo, and the operator for that is the percent sign. So num modulo 2 is 1. So it's 11 divided by 2. What is the remainder? It's 1. Modulo. So if we had num be 12, for example, right? num modulo 2 would now be 0. There's no remainder. If we did num modulo 3 on 12, right, 0. If we did 4, 0. If we did 5 now, it's going to be 2, because 12 divided by 5 is 2, remainder 2, modulo. The order of operations, as everyone think back to like when you first learned early math, right? The order of operations is the same in regular algebra as it is in JavaScript, right? So if you remember the acronym PEMDAS, it stands for parentheses, exponents, multiplication, division, addition, subtraction. That's the order of operations. So if we were to have a line of code that was like a bar mynum equals 5 plus 2 times 3, right? The parentheses are going to be evaluated first, so it's going to be 7 times 3. Right? And if we look at mynum now, yeah, it's 21. These rules apply regardless of where they're at, right? So I could do minus 2. Right? So now it's 5 plus 2, 7 times 1. So the answer is 7. Mynum. Everyone remember the order of operations? This will trip you up when you're writing complicated mathematical formulas in your code if you don't remember the way, the order of which they'll be evaluated. Order of operations, PEMDAS. Where does modulo fit into PEMDAS? Let's see. What is one we can do? Let's do 3 modulo 2 times 2, right? So if modulo happens afterwards, it would be 3, well, let's do 5. Let's see, 5 times 2 modulo 2, right? So we would expect this to be like 2 divided by 2, right? That should be 0, right? If we, let's see, 2 modulo 2. Modulo 2 is 0. So if I do 5 times 2 modulo 2, is it going to give us, it's telling you the answer. Modulo is happening before the multiplication. Do you see this here? If these were in percents, right, it'd be 5 times 2, that's 10 modulo, oh, let's make this a different number so that it's, right, so 10 divided by 3 has a modulo of 1. Let's see if we take the parentheses out, right? So it's interesting. So it's 5. What is 3? 2 modulo 3. 2. Yeah. So we put this in parentheses. Yeah. 2. What did we have before? Not 3. So 10 compared to 1. So the modulo is happening after the multiplication, or maybe even at the same level.
Order of operations go from left to right.
Yeah, left to right.
So
if
you
we
put
move it around, let's see if that
yeah.
changes anything. Let's do 2 modulo 3 times 5 times 5. So it's giving us 10 there. So I think modulo is being treated at the exact same level as multiplication. Yep. So, and it's left to right as well. So just be aware that this can trip you up when you're writing long, complex algorithms. Always remember back to PEMDAS so that it keeps you out of trouble. There's also a built-in math object that does a lot of really cool stuff for us. So if we if we type in math, right, you can see that this is an object built into the browser, and it has a whole bunch of properties that are in here by default, right? So some of the ones that you'll need for complex mathematical equations, right? Like so math.pi, for example, if you need to use that, right? Math.pi is going to be the value of math, the value of pi out to what looks like 12 or so decimal places. But you can use this object and its properties safely inside of any algorithm that you need to in JavaScript. There are also a bunch of really powerful helper functions in here. So like math.ceiling, math.floor, or let's show this off, right? So math.floor is going to take a value, right, like 5.676, right? And it's going to floor it down to the lowest number, right? So the lowest integer. Math.ceiling is going to go up to the next highest integer. There are a whole bunch of really cool functions in here. So math.absolute is going to give us the perfect value that comes out of this. We also have a built-in square root function. So if you needed to do math.square root and we do 25, right, it gives us the square root of 25, which is 5. If we do the square root of 124, right, 32. If we did some number that doesn't have a nice clean square root, it's going to quickly give us its best approximation, or the closest it knows it can get. If we needed to do powers, right, so we could do math.pow, and that takes an x and a y, right? So if we do 2 to the third power, it's going to give us 8, right? 2 times 2 times 2. Do 2 to the fourth power, 16. 2 to the 22nd power, 404,194,304. So the math object has a whole bunch of really powerful functions in there for, like, if you ever needed to use some of the more complicated features of like a graphing calculator or some of that, there is a function built into the math object to support that use case, right? And if we just type the math object and we look at some of these options in here, if you ever need to do, they've got cosine, a cosine. You've got some stuff in here for tangents, square roots, sines. You can do logarithms, log 10. A lot of really powerful functions in here that if you did not have this math object available to you, you'd have to implement those algorithms yourself, right? So you can imagine, this object is saving you 10, 15 lines of code in some cases. Complicated math. And the precision is good enough usually for most applications that you'll use in JavaScript. Now, if you're working for some reason, maybe you go work for, the U.S. National Laboratory or something, you're working on some radiological experiments and you need a website for it, the math object is probably not precise enough for that kind of work, where you're actually working with real-world data. This is great for approximations, and it's great for, like, how many cars were in our parking lot this week, like simple math stuff. The precision is not good enough in JavaScript for that type of application. You'd have to probably use an open source library in JavaScript to get more precision or more accuracy. So just be aware that if you're working in a scientific field, just verify the correctness of the results of the math object's algorithm, right? Any questions about the math object? This is this is a really powerful object built in. I've used it, thousands of times over the last 20 years, and it's really good at what it does because it's extremely fast. It's like baked in, right? So instead of us calculating the square root of a number, right, we can use math.square root and have it do it in the browser layer, in C++ or whatever. So it's going to be quite a bit faster than code we could write ourselves. Just as one example. Like math.square root, right? If I put in some giant number, that gave us the result almost instantaneously. If I needed to try and calculate the square root using the actual algorithm and writing it in JavaScript, it would probably take, 10, 15 seconds for it to execute. Cool. Right, another fun one, right? We're going to spend a lot of time talking about this, math.random, right? So by default, math.random is going to return a value to you between 0 and 1, and it's going to be random every single time, okay? So this is how we introduce some randomness into our programs. When we were showing off that project from Leah of her blackjack thing, right? She has 52 cards. She would use math.random to select a card out of that deck randomly. Can anyone tell me how I can take a number from 0 to 1, a floating point number, and turn it into a random number between 1 and 0 and 1 and 52? If I wanted to pick a card out of a deck, if I got 52 cards, my only valid options are 1 through 52, right? So how can I do this? Josh, go ahead. What do you think?
You could try to multiply that random number
There's 52.
And then math.floor that.
Yeah. Floor. Yep. That's exactly right. Generally, what we would do is I might do math dot. Yeah, math.floor or math.seal would work as well. The one thing you have to be aware of, right? So floor always goes down, seal always goes up, right? So if the true value of math.random, right, if this gives us 31.21, if I use math.floor, it's always going to be 31, and if I do math.seal, it's always going to be 52. And so if I had to pick a number between one number and another, right? If I had said times 53, for example, right? You just have to be aware that like you're introducing a bias in one direction or the other. So just be aware that that's a possibility, just to be aware of. And also be aware that math.random in here is pseudo-random, right? It's not like I would not build a banking algorithm that relied on the randomness of math.random. I would not build cryptography off of their random number generator here. This is just a good approximation of random, good enough for like building a simple video game and stuff. So, go ahead, Karif.
Is it possible just to read the first number?
Which part?
Everything before the decimal?
Oh, like 47.8?
Just 47 instead of the 0.8.
Yeah,
This is right.
that's what math.floor and math.ceiling are doing, right? So math.floor is doing exactly that, right? Like, so if we took this number, 47.83, whatever, right? If I do this, and I put this in math.floor, right? It's just reading the 47. The problem is if I take that same number and I do math.seal, right? It's going to 48, so it's like rounding up. So you have to be very careful of, it's equally likely that, this random number generator is going to have a value above 50.5, right? So between 0 and 0.49 repeating, right, is going to be the lower number, and 5 on up to 9 to 0.99 repeating is going to be the higher number. So I'm not sure specifically if math.random is random enough for it to matter, or if it like is predisposed to pick numbers that are on the lower end. You'd have to almost do like some kind of regression testing, or even look at the browser source code to run wide scale numbers to see like, okay, I got, you'd probably want to test it like this. You'd like generate a random number 1,000,000 times and then figure out if there was a distribution that was statistically relevant of like the number of times that it was above 0.5 or below 0.5 to figure out if it was safe to use with .seal or .4. Because you can imagine if you're building a casino app and real money was on the line, and you were counting on it being, equally distributed, but you have a thing that was slightly weighted in the favor of, a less than favorable outcome for you, you could lose a lot of money. So I would just say math.random is great for simple random number generation, but be very cautious if you're using it for something that has real-world implications attached to money, right? Like if you're actually building a poker game that people could bet on online, like verify first, because there are better randomization algorithms that you can maybe use that will do some of the random number generators like will actually read a person's mouse movements to generate random numbers, because this is going to be unique to me, like how many times I squiggle around and what their positions are. Oh, the other thing to note, and I'm glad I have this little note in here for myself, is that when we're doing these random numbers, right, because I said I wanted a random number between 1 and 52, okay, we always have to add 1 to the end of this. And the reason is because it starts at 0. So if I want 52 to be a valid answer from math.floor, right, then I have to add a 1 at the end. Because otherwise, 52 will never get selected. And let's show this off. I'm gonna pick it as like 5, right? Eventually we'll get a 5 here pretty quick. Yeah, see, there's a 5. If I took out this one plus 1, we will never get 5, but we will sometimes get 0. Okay, so that's, be aware, whenever you care about the number between two numbers, right, between 1 and 10, 1 and 52, you always have to add 1 if you're doing math.floor. If you're doing math.ceil, okay, you might have the problem in the opposite direction. You might have to subtract 1, right, math.ceil. Because now, I don't think we will ever be able to get 1. Or we'll never be able to get 0 if we cared about that. So minus. Yeah, so now 0 is an option. All right, so whichever direction you're going, either add or subtract if you care about it. If you're doing between 1 and 52, make sure you add a 1. If you're doing between 1 and 10, make sure you add a 1. If you're using math.floor. Cool. Now, often, well, we'll talk about that when we get to arrays. Any other questions? Did someone raise their hand? Mm-hmm. Go ahead.
I just wanted to add that so I spent a whole lot of time like dealing with randomness, random number generation, and everything. And yeah, I was just gonna add on too that usually if you're using sort of the out of the box like random function from whatever language, they'll usually use something that's very like mathematically sound and has been tested by countless researchers for any sort of bias or whatever. So from what I understood, the problem was not necessarily that there could be any bias in the numbers, but more it was that the numbers could be predicted if you saw a long enough stream of numbers, and it would have to be a really long stream of numbers. But just out of an abundance of caution, they use the cryptographically secure random number generators. And I also just wanted to give everybody that link, give some important learning about JavaScript through memes.
Nice.
So yeah,
that's good. Everybody enjoy that link. That's pretty funny. Yeah, and I mean we could test out the like let's make an object, right? So we'll say randos, and we'll say we're gonna make 2 values in here. We'll say less than, and we'll make that a 0, and we'll say more than, make this a 0. And what we can do is we can write ourselves a loop here. We'll say for var I equals 0, and we'll just test this a million times, right? I is less than 1 million. Yep, 1 million. And we'll do I plus plus. And what we'll do inside this loop is we'll say math, let's say var rand equals math.random, right? If rand is less than 0.5, we're going to increment randos dot less than plus plus, else randos dot more than plus plus, right? So we're just going to count this, and we're going to run it a million times and see how many of them are above 0.5 and how many of them are below 0.5, and just see if there's any kind of pattern, right? So then let's go to randos. All right, so we see that less than was slightly higher by like 400. Okay, is that statistically significant? I don't know. Let's run it again. Let's just create the variable. Let's clean this out and run it again. Randos. Oh, look at that. Less than is still higher by about the same amount, twice. That's interesting. Let's make it again. Okay, now we finally have more than being the, so they're going to be close regardless. Okay, but it looks like there's maybe not much of a bias one way or another. But to Eric's point, what he was mentioning is that like the random number generator, and here's a pseudo random number generator. It's a good random number generator, but it's predictable, right? So if you were trying to generate, tokens or something, if you were seeing a bunch of these random numbers time after time after time, you can predict which one will come next in in that chain. So if I was building Venmo or something that submits transactions and it was signed with a key, if we were using this math.random, I could pick one of these numbers that I know is going to come up next, possibly, and then forge a transaction between Karif and me and say, Karif paid me $1,000. So there are better random number generators than this one. Cool. Any questions? We've covered a lot today. That is the end of what we're going to cover today. Tomorrow we're going to get into arrays and more into objects. Some of the more interesting data types that we're going to build our applications with. But these are all the natives and all the primitives and all the things that are like the fundamental building blocks of JavaScript in our program. We learned how to embed JavaScript into our programs with internal and external scripts. And we've learned a little bit about the math of JavaScript. Anyone have any questions? Anything at all that you would like to go over or wasn't maybe that clear? We're going to try something new today as well. Selena has been hard at work making a little short quiz for us. We're going to do that live here in class and see how well we retain the information from today. This is our first time ever doing an in-the-class quiz. I'm very excited. Any questions before we do the quiz? Is it ready, Selena? She's shaking her head no. She needs one more question to put in it. Oof. Do I just ship it with 9 questions? I don't need 10.
Just one more.
No, there's no time for one more. There's not one more bit of content.
I think I completed that quiz already.
You could not have. It hasn't been released. She's
There was
writing.
one released about 4 o'clock.
No, she's writing a new one. This is brand new.
Oh.
This is about what we covered today.
For today?
Yeah. We've never done these kind of quizzes before, and we're experimenting.
Just don't kill me with data types.
Oh, we're killing you with data types. Add another data type question, Selena. All right. Well, while she's finishing that up, let's take a quick break. It's 6:54. Let's come back at 7:05. So just a short 10-minute break. Get a soda. Go to the bathroom. We'll come back and we'll do a quiz. Okay.